During this class, we will discuss another important topic, and you will learn about another important topic, which is called elasticity and what role elasticity plays in case of solids. So here it is. Elasticity is the property of a body to restore its original size and shape when the deforming force is removed is called elasticity and the body is said to be elastic. If you hold any steel scale in your hand and you bend that scale, after bending, you see the bending of the shape of that scale and notice it. After few seconds or the minutes, to release that force or remove that force, you will see that this scale is moving at its own place, which was before application of the force. To the other sides, in the simplest language, it has attained its original state again. This property of the body is called elasticity. But what's the opposite? If you take any type of other scale, plastic scale, you apply a force up to a limit, it will hold and it will come back after removal of the force. But beyond that limit, if you remove the force, it will break. If you before removal of the force, you apply the more force, it will break. It means it is not regaining its original state. So that is basically plasticity. But this time we are studying only elasticity. It is the range up to which if you have applied force on the object, you can bend or change the shape of the object. But if you remove the force, the object regains its original position of the shape which was before the application of the force. This is basically property of the solids which is called elasticity. So let's start. Here it is. The property of a body to restore its original size and shape when the deforming force is removed. I have given you the example of a scale. There are a number of other examples which are applicable, which are very much pertinent for this type of topic. Where when you apply a force, you change its size and shape. You change the shape of that object. But if you remove the force, the object regains its original state. That type of the property of that object is called elasticity. What is deforming force? The applied force that changes the shape, length, or volume of a substance is called deforming force. If you have a juice can, empty juice can or milk, you apply a force with the help of your foot, which you have done so many times. Basically, you have changed the volume of that object. At that time, what you have done, you have applied a force. That type of the force is called deforming force. It's another question, it will regain its initial stage or not. If it regains, then this property is called elasticity. And if it does not regain, so it breaks, that is called plasticity. So here we are only concerned with elasticity of the object. So here it is. If you take a rubber band, you apply a force, you stretch it. After stretching, you have changed the position or the length of the object. Suppose before that it was of this size. And after application of the force, you have stretched it. And when you will release it, again it will be gaining its initial size and the shape. This type of properties are elasticity. Same is the case of a spring. When this spring is at this length, you apply a force, you stretch it up this again you apply a force and it stretches up to this. When you will remove the force, the spring will regain its initial position after the removal of the force. Force is mean you keep on increasing these weights. Weights are basically source of force. Keep on increasing. The more you increase the weight, more will be the increase in length. So if you start decreasing, you have decreased one more weight, you come back at the same length. When you have completely removed the whole weight suspended, then you will gain this position. So it means that after removal of the force, if the body regains its original position, you have stretched the elastic and then you release it. You have basically removed the force. It will come back to the same size. This type of the property of the solids is called elasticity. But let's understand with the help of an explanation. When an external force is applied to an object, the size and the shape of the object may change, like we have seen in case of elastic band. This change produced in shape size of an object is equal to the elasticity. When we apply force to pull a rubber band or a spring, it may elongate. When the force is removed, the rubber band, the spring returns to its original shape. Elasticity of a body depends upon the nature of the material. Yes, it depends on the nature of the material. You can't apply the same technique on the iron. You can't apply the same technique on the wood. There are different values for different objects. It is different for plastic, it is different for wood, it is different for glass, it is different for other objects. The values of elasticity are changing. For more elastic material, more efforts is required to produce a change in the shape, size, and the volume. Steel is more elastic than rubber because more efforts or force is required to bring a change in steel than in rubber. Basically, you are so many times you are asked which one is more elastic. Steel is more elastic than the rubber. Why? Another logic is that when you bend rubber, after and before you see it under electron microscope, you will see in case of rubber band the atoms are displaced anyhow up to a little friction when a application after removal of the force the atoms were displaced. But in case of steel, you bend a steel scale, and after bending and stretching, you will see at the end the displacement of the atom from the mean position is very much less after bending. So this is one concept, one logic that this steel is more elastic than the rubber. So, another logic is given here as well. So steel is more elastic than the rubber. This question is asked in the exam. Which one is more elastic than the other? So because more effort or force is required to bring the change in the steel than in rubber. This today's class ends. I hope you people have understood. Thank you very much for your question.